Okay, great. Thank you everyone for joining us tonight. And thanks to the Township Parks and Rec Department for sponsoring this. Here is an outline of what we're going to talk about tonight. We have 4 speakers here. Sam is going to start off talking about his experience. He's electrified his whole home, and he just informed me that his all the cars in his house are now electric. A real champion and a real hero local we have in our township. Joy and Hank are going to talk about next some other things you can do inside your house that are less costly than heat pumps, like induction stoves and water heaters and heat pump dryers. And then finally, I'm going to really dive into heat pumps. Hopefully we'll have enough time. We're going to try to move pretty briskly, realizing the amount of material we have. I have 2 other intro slides, which I'll go over. But before we start, I just wanted to do a little quiz here. And you can either use the chat or I don't know if people are muted. In the picture on the right, can people identify which of these is a heat pump? The left or the right or both? Okay, it's okay if no one is. So this, if you see these kind of things like this on the left, these are heat pumps, so they can do both heating and cooling. The one on the right, I would say, looking at this, I don't know. It could be a heat pump doing both, or it could be a an air conditioner condenser. And one of the reasons why I wanted to do this is, if you have one of these in your outside, you have a ducted system, it's the easiest and simplest replacement to switch to a heat pump. So whenever you see a house that has these, you would pretty much have to replace this unit, which only does air conditioning, with a heat pump that does the same job. And it's very simple. I just wanted to open with that. Next slide. This is a reference slide. We're going to share the slides. These are all links. There's a lot of useful information we're going to go over here. This getting started here is a link in the New York Times Wirecutter app, which is you can get on your computer. It's really like, how do I get started? How do I find contractors? How do I screen them? There's links in there to find contractors who are trained and certified by the top manufacturers like Mitsubishi and LG. So this is a really good resource. And finally, there's other things we'll talk about here. But one of the most important things, if you are really seriously considering this, please reach out to us. And there's this haveswitch@gmail, which is the friends of the Haverford EAC, and they'll pair you up with me and Sam. And what we have done is we work with homeowners to really look at your house and or your bills and really advise you through this process. It's pretty complicated. And or when people get bids, we'll sit down and look at the bids from the contractors. There's a lot of variables in play, and we're just going to touch on some of them tonight. But the point here in this, if you can write this down, if you are interested, we between the 2 of us, we have a lot of experience to walk you through this. This slide here is a really high level of electrification for your house. So there's a lot of things you can do. We've all heard about solar and electric cars. But all the other things below this, except for the yard equipment, we're going to talk about tonight. And I have these little icons here about how much carbon would you reduce were you to do it. These are the little trees. So the big things you can do, and how much would it cost to do this, and or complexity. Solar PV, electric, and heat pumps for your house are going to really knock down your your carbon and your fossil for your house. These are the big threes. These two, solar and electric cars, are actually simpler than heat pumps, believe it or not. But we're going to try to demystify that tonight. The other ones, which Joy and Hank are going to go over, and Sam actually too, are heat pump water heaters. And you can see heat pump water heaters still reduce a good amount of carbon. They're moderately expensive. So the $3 here, we're talking tens of thousands of dollars. Here we're talking, you know, 1,000, 1 to 2,000-ish in that range. So this is significant for your hot water. Electric clothes dryers and induction would be in that same range, maybe a little less, and reduce carbon a little less. And very inexpensive, but marginal carbon would be to do yard equipment. We're not going to cover that today. With further ado, I'm going to introduce you to Sam, who will walk you through his experience.
Hi, my name's Sam. I've been sitting here on the side. Who is this guy? I'm a local Havertonian. I live on the Lanark section of Havertown in a small twin house, which we can go to on the next slide. But I'll talk about my motivation for why I do this. I'm an avid environmentalist, and I'm also in construction. The two together allowed me to go ahead and do a complete electrification of my entire residence, not only with the house, but also with my cars. So, and I also have a very tolerant wife who allowed me to do this because I did this all on my own. I was able to save a lot of money by saving on labor, by putting in my own effort. But that's not to say that you can't do it, because there's a lot of tax incentives to do this, and it is very doable. It takes a little time, but from my experience, I hope you can glean that it is very, very doable. So this is my house, nothing special from the outside, and it looks exactly the same pre and post in terms of a pre and post non-fossil fuel house. And as Steve alluded to, as of a few days ago, we don't burn any fossil fuels at all. Everything we get is either produced on site or from the grid. And as the grid gets cleaner, ultimately the goal is to have a completely fossil fuel existence. And this is what the goal should be, at least in our group, for everyone who wants to decrease their impact on the planet in terms of their in terms of how they live. So next slide. The first thing that we did was we got involved with the solarized Delco, and we got a solar array installed on our property. It's on our garage because it has the most solar available. Unfortunately, we have a tree that shades our main house. So we installed a 3.7 kilowatt array on our garage. It was a very pleasant and doable experience that Solarized Delco made very, very doable by grouping our solar installation with many other individuals in the Havertown area, which made it competitive and eminently doable. We took advantage of the federal tax incentives in order to decrease it by a third. And the installation only took 2 days. It was the connection to the grid that took a little longer. But if you want more details on that, I'm more than happy to tell you about that beyond this presentation.
One comment, Joy, that have switch email I sent, is that the right one if people are interested in Solarize? Won't they be
I'll put the Solarized Delco email in the chat.
Thank you. Okay,
Great. So the next thing that we did is, considering the amount of electric usage that we were going to anticipate using in our house, considering that we were going to go completely electric in all our needs in terms of transportation, as well as heating and cooling, and cooking and cleaning our clothes, pretty much everything. We decided personally that it would be better to upgrade our electrical panel from 100 amps to 200 amps. It may or may not be necessary for you, depending upon your electrical needs. Think of electricity as a river. The water coming in is the electricity. 100 amp service is a certain size flow, but a 200 amp service is a much larger flow. And again, depending upon how much electricity you use, we can determine whether you may need to upgrade to a 200 amp service. And again, there are tax incentives for this as well. These are the two of the heat pumps that we use in our house. These are the two Mitsubishis that we use. They are high efficiency heat pumps. And I have to tell you that they've been very, very wonderful in terms of their heating and cooling usage in our house. We sized them appropriately once we went through our house and closed off any air leaks that we could possibly find. You have to remember that I went through some extensive air sealing in our house because I gutted pretty much the entire house as I was going through this process, and spray foamed the entire perimeter of our house so that we didn't have to have a huge heat pump when we did do the installation. So, but just because we did that doesn't necessarily mean that you have to go through such an extensive process. A heat pump can be sized appropriately for the sun exposure of your house, for your insulation that is currently in your house. And you can find that you will have a smaller sized heat pump the more you go for the lower upfront, low-hanging fruit of air sealing, insulation, and general efficiencies that go before all these major projects are undertaken in your house. So for our house in particular, we have one heat pump for each zone. We have a basement heat pump, a first floor heat pump, which is an open concept. So we just have this one terminal that you see on the right, and that heats and cools our entire first floor. For those that are geeking out, the one in the basement is a 3/4 ton. The first floor is a 1 ton. And the second floor, which has multiple rooms, I did a ducted heat pump. And that goes to each of our individual rooms from a central unit that I have in my bedroom closet, which I can service from there. So they have come in multiple different varieties, but this is the classic one that you'll see when you think of a heat pump in terms of a terminal. But they do come as cassettes that you can put in your ceiling. They come as wall units. They come as ducted systems. They come in all shapes and sizes and varieties. These are the residential units that you see here. This is a heat pump dryer, the one that you see at the top. It's a Miele version. We're going to show a little demonstration of how this works on a physics level on a later slide. But in essence, it uses a third of the electricity by using a heat pump. And a heat pump is, in essence, an air conditioner that works in reverse. During the summer, your refrigerant takes the heat out of your house and dumps it outside. In the winter, the refrigerant just flows in a different direction, the opposite direction. You can take heat that's outside. I know it sounds a little ridiculous, but in the winter, there's still heat in the air, which is taken, thrown into the refrigerant, cycled into your house, and dumped into your house. And that's how a heat pump works at a layman level. And a heat pump dryer takes advantage of heat pump technology to dry your clothes. It takes a little longer. This version is a little smaller than your standard American heat dryer that you're used to, but I can put this in my bathroom upstairs, and I don't need a vent for it, which makes it really nice. I don't have to vent. I don't have to have your standard conventional metal duct going out to the side of the house. This one just has a little drain that goes into my washing machine drain behind this unit, and it makes for a nice compact, clean look, and it works very nicely. Next slide. This is my heat pump water heater. This is a Australian Sandon heat pump, not typically sold in the United States. This is very uncommon. I had to search high and low for this, but the ones you'll see later on the slides are your ones that you'll see in more commonly in the United States, where the heat pump is actually on the top of the tank. This one just happens to be split into two sections. And it uses carbon dioxide as a refrigerant, compressed carbon dioxide. So it has very little damage if it happens to leak refrigerant, but that's a little beside the point, a little too much into the details. But what I can tell you is that my heat pump dumps, it takes hot air from underneath my porch and dumps it into that tank that you see on the left. And that's the basics of it. And I have not had a problem. I have nice, abundant hot water, even during the coldest of months in Pennsylvania. Next slide. This is my induction stovetop. It is not a heat pump. It cooks without fossil fuels by using magnets, using the power of electromagnetism to cook my food. And it does it a lot more efficiently and a lot quicker. I can boil water 50, if not 20 or 75% faster than the average stove that uses gas, and a lot more evenly. And it has a much finer tuning of the heat. And even better, I've got a lot of cats. When I'm cooking, there's no safety issues if a cat happens to be walking by and he peers into the boiling water and says, "Oh, that's interesting," and then walks off. So it has that safety element in there as well. And it's been a dream. And that particular unit cost $1,000 off of Facebook for a person that just didn't like it because it didn't have a hot air fryer in there as well. Go figure. It's a wonderful, wonderful addition to my house.
What's the manufacturer?
That's a GE.
GE.
Okay. Next slide. And that's pretty much it. What I want to add is that's the unit that I have on the right. That's the Sandon heat pump. The one that you see on the left is the one that you'll typically see in the United States. The condensing outside unit is on the top. So it takes the heat that's in your room where that unit is and puts it into the water that's underneath the heat pump portion at the bottom of the tank. The problem is that in the winter, it takes the heat out of your house or out of your basement, if that happens to be where it is, and makes that room colder. That's why I bought the unit on the right. So if you want to go all out, that's why I got that unit on the right. But if you want the cheaper option, but the one that will still work as a heat pump hot water heater, go for the one on the left. I think that's the end of my presentation. I just want to add that I do have two electric cars, and they've been running wonderfully. I had very little problems with them, very little in the way of maintenance issues, but those are talked about a lot more in the general media than what we talk about here. So that's pretty much my story.
And I'm Joy Baxter. I'm the co-chair of the Haverford Environmental Advisory Committee. We usually call ourselves the EAC. And one thing to note about the federal incentives for this, a lot of things came through the Inflation Reduction Act. on haverfordclimateaction.org. There's a little icon on the homepage, and you can click this, and this will take you to rewiringamerica.org. It's one of the links that Steve shared in the beginning. And it talks about what not only what is eligible for the credits, but you can enter in your income. It doesn't save anything, but it will tell you basically if you're in the low income or the middle income or the high income, because that matters for some things. For heat pump hot water heaters and for heat pump systems, they're whole house systems or even just a single unit. You're eligible for up to 30% off the installed cost, up to $2,000 as a tax credit per year. If you want to both do a whole house heat pump and a hot water heat pump in the same year, I would suggest maybe splitting that, because then you could be eligible also again the next year for that up to 30% of the installed cost, up to $2,000. There is also upcoming in late 2024 instant discounts, and those are being rolled out by Pennsylvania. The money's coming from the federal government, being rolled out by the Pennsylvania Department of Energy. The specifics of that have yet to be disseminated. You can get up to $1,750 off the heat pump hot water heaters. This is geared towards low and middle income people, people who would not be necessarily be able to use a tax credit. The guidance is it would cover up to $1,750 if you're at 100%, if you're low income, and 50% of middle income, but it's state dependent. So we have to find out what will come next. Next slide. So I did some comparisons of 40-gallon hot water heaters. There's a lot of information here. I just want to point out that the hybrid, can you go back to the previous slide, Steve? So this hot water heater is actually a hybrid. It's both heat pump and elective resistive. That's most of our electric appliances in the past have been just resistive heating. Just like a toaster has an element that heats up because the electricity is not able to flow well through that, so it creates heat. So the same thing, that's what most of our electric water heaters have been. This adds the heat pump, but also has that kind of backup resistive heat as well. You can go to the next slide. So that's why I'm calling this a hybrid. And then I call the split. The split is more expensive than the hybrid. And then your electric resistive and the gas hot water heaters, just the unit themselves, not the installation. I did not know how to compare that for everyone because everybody's situation is going to be different. They are significantly less at the beginning. However, with the utility costs of running them, if you look at the elective resistive one, you're at 10 years, which is generally the lifetime of these units, right? That you're at $6,300. Where if you got the hybrid hot water heater heat pump with the 30%, you're at $2,500. The carbon emissions are much less for the heat pump hot water heaters. If you have gas and you just say, I'm just going to go to the elective resistive, you're actually not going to be saving emissions if you are using electricity from the grid. This is using our mix of how decarbonized or how much carbon is in our grid. So that's just kind of idea. So better to go to the hybrid or the split heat pump unit. Now, for considerations, one of the benefits of this hybrid heat pumps, if you have them in your basement in the summertime, it acts as a dehumidifier. So that's one of the things to consider. Another thing is it's noisier. That's because it has a compressor similar to your refrigerator that will run just like your refrigerator has a noise. And it also has a fan when it's running. So there is a noise to it that that you don't have with your traditional. Of course, that noise with the split system would be outside. It has a little bit of slower recovery time. That would be the time like after you've used up all the hot water in the tank, how much time it gets to go. So it depends on your family situation. And like Sam said, it would be cooling the air. It would be cooling the area in the winter, but will also be cooling it in the summer. So you might be losing a little bit of the heat in the winter time, but you're also going to be reducing your cooling needs in the summer. So that's kind of an idea of what you're looking at with the hot water heat pumps. Next. And can you run that? Great. So this is from Energy Star. It's a video from Energy Star that we're just going to share. Steve, we're not hearing you're muted.
The innovative way it saves energy. Notice there's no heating element and no vent. But why? A heat pump uses technology similar to an air conditioner, but operates in reverse. Air is pulled through a condenser where it is heated before entering the drum. The hot air then absorbs moisture from your clothes. Next, the damp air goes into an evaporator, which removes the moisture and collects or drains it. The real savings happen next, when that same air is pulled back through the condenser to be reheated while still warm. In other words, we save by recycling warm air instead of releasing it through a vent and using energy to heat new cold air. Now that's a good use of hot air. So remember, while on the outside this dryer may look the same as other dryers, it is special because the heat pump technology on the inside uses 50% less energy, and that's 100% great for us and the environment. Find your Energy Star certified heat pump dryer. EnergyStar.gov/HP dryer.
So I looked at a couple of different heat pump clothes dryers. First, I just want to go through the pros and cons. So one of the biggest pros that people really love about these is they're ventless. So that means that it's much easier for people to put them in places that are not usually where washers and dryers are. And especially people in apartments and condos love this. They're more efficient. But you can add a drain, or you can have it dumped. But obviously, if you're going to have a washer nearby, you're going to need a drain. It's gentle on your clothes because it runs at a lower temperature, and it's cheaper to run. But you're not going to be saving a lot of money. And actually, this goes for all of these types of changes. These are usually changes that were recommended at the end of life of your existing units. These are not changes that you're going to go out necessarily and do just because you want to make the change, or at least they won't pay off in that way. So when you need to get a new hot water heater or a AC or heater or a dryer, that's usually when you would make these changes. Also, I didn't see this, but I don't see why this would not be true. It's definitely safer because of that. You don't have the risk of the dryer lint fires in your vents. So those are things to consider. Some of the cons. It's more expensive up front. So I did a quick search. I think this was on Best Buy to kind of get a range. So the heat pump dryers for $800 to $2,000. Electric, you can see the numbers. It does dry the clothes slower than a traditional dryer. So some people, if you're used to the speed at which the more inefficient dryers dry, these might not be for you. Also, generally, they are generally a smaller size capacity. That's pointed out in this picture here. So this is the traditional size of these heat pump dryers. However, there are some newer units that are hybrid that have both the heat pump and the resistive heating that can successfully do a normal, what we think of as the normal full-size dryer. Also point out there's some really cool products out there that is a washer dryer system. I've actually used one of these before. It's really cool. And the same thing goes for the incentives. There's no tax credit on these, but there will be incentives. But again, they're not active quite yet, expecting in late 2024. Next. Hank, did you want to do this section?
Hank on mute. Hank on mute.
Okay. So
Oh, there I go. I'm sorry. I was hitting the wrong unmute button. But I think my internet's a little flaky tonight, so if it's not good. On the induction is a different, as Sam had mentioned a little earlier, is a different way of heating your food. It really does not heat the surface of your stove. It actually uses magnetic fields, and that heats your pot. So it's much more efficient. It also is very comparable to gas when it comes to the minute control that most cooks like about gas. And in fact, we had gotten a portable unit here at our house just to compare, and you do get a very quick, responsive control of induction. So, other than that, I guess that's about it on the technology of it. But you can get, as Sam said, you can get whole ranges. You can also get portable units, as I had mentioned. We got it just for testing purposes and also to cook outside in the summertime. So that has proven to be quite effective. And as Sam said, also, I've done my own testing, and it will bring a pot of boiling water as fast as a power burner on a gas range. So, it has all the advantages of gas and the efficiencies, more efficient than electric, and clean burning. So, I don't know.
next
Did I
slide.
cover that pretty well?
Yeah, I'm just going to go over this. So,
Okay.
I have to say, I wish I knew all this before I switched my stove to gas. So there is a lot of new research out there talking about kind of the indoor air quality dangers of having a gas stove and oven. This picture here on the right is a graphic showing the indoor air of nitrogen dioxide. So the US and Canada have some safety limits of what indoor and outdoor levels are. And all of the indoor ones for cooking that use a gas stove have been measured way above the recommended indoor. This goes also for not only nitric oxide, but nitrogen dioxide, but also VOCs and everything like that. So there are actually, beyond emissions, like just carbon emission savings, there are safety reasons to switch from gas to induction.
Joy, if I could cut in one other safety thing is if say people that have memory issues are in the house, or special needs or what have you, the safety things that Sam mentioned about this. You can just leave an induction on and you can put your hand on it and you're not going to get burned. The risk of having gas either lit or unlit especially in those cases, is pretty big. My uncle's having a lot of pre-dementia, and his my cousins replaced his stove with an induction for that reason. So that's just another safety thing to add to your slide here.
In addition to not having it get hot, most induction won't turn on unless a pot is present.
Okay.
So about availability and price, these generally are fairly comparable, especially if you can get them on sale. So a quick survey, you could look at the range of prices I found at Home Depot and Lowe's and the comparison to gas and electric. So these are very much in line. Again, with the incentives, no tax credit, but there will be an incentive coming from Pennsylvania up to $840, which is income-based. Next. And these are the actually pictures of Hank's portable induction units that are very affordable, and you can try it out.
Geez, I'm looking at those flowers and missing summer.
Mm. Okay, we're gonna pivot now to heat pumps for space heating, and I'm gonna cover some quite a bit of material in the last 20 minutes here. As Sam mentioned, before you do any of these things with high electric load, you should really check your panel to make sure it can hold. If you look, this is my panel. You can see my got my chargers here, but at the very top, the top breaker will have the amperage. This is a 100 amp panel. Do you need 100 or 200 amps? There are some tools on the web that you can use for sizing. There's a lot of things on YouTube to see if you do need to size it. But that's a very important thing to think about. I'm going to just give another quick overview of what is a heat pump here. Hopefully it'll make some sense. I think Joy and Sam both talked about this. But if you think about water and a water pump, I think we all understand it. Water spontaneously flows from high levels to low. Like this is a case where we have a dam, right? It will always go down. And then you can capture that energy with a generator, and that's how that's how hydro works. You can also put pumps in this station and pump the water back up. The water does not want to go back up unless you have a force, and the pump is the force doing that. And by the same token, this is what we were just talking about. Heat always moves from warm to cold. But a heat pump will do the same thing, essentially push the heat in the direction it doesn't want to go. So in a day like today, where it's like 30, it'll push the heat into your house, which is 70, and you have to add electricity. But there's so that's how it works, and it's no different than an air conditioner like we have here, which is taking cooler air from the inside and pushing it to the outside. I wanted to before we one important thing for heat pumps to really drive home, and if you remember anything, is heat pumps can work very well in very cold weather. 10 or 20 years ago, the technology was not there, and people would have to put in gas backups, or they would not use heat pumps at all. But there is so much innovation in the heat pump market. I work for New York State's incentive program, which has over $1 billion a year in incentives for homeowners to switch. And we require that every single model be registered in this database of, it's called Northeast Energy Efficiency. It's neep.org. So all the units in here are rated down to 5 degrees outside with a minimum efficiency. So that's pretty amazing on that cold day. And now they're starting to go even lower, well below 0. So they're rated with how much heat they can give. And right now, as of today, there's 128,000 models listed. So you can just imagine the innovation and competition among manufacturers to deliver really good products. There's also a little filter. If you go on, you can click and you just click on the north for federal tax credits. But if you click on that, I just did it, only 46,000 are eligible for the tax credit. So if you talk to contractors, always say, I want one that's listed on NEAP and I want one that is eligible for the tax credit. And you can verify this yourself. A lot of contractors may not be as experienced. They may try to sell you something that's not as efficient. A lot of contractors will try to sell you something that will require gas on cold days. It's not necessary today. I'm going to go over the different types of heat pumps pretty quickly. And there's a lot of variety here. But basically, if you were following what Sam was saying, there's a part in the inside of your house that delivers the heat. And there's a part on the outside that in the winter will take heat and put it in your house. And so you can have a lot of different combinations of where the heat comes from and how it's delivered. And air source are the most common by far, and that's what Sam was showing. And they have this little unit on the outside here. That's what I showed in the opening slide, that is taking heat from the air in the winter and putting it into the house. And if you have ducts in the house, like we were talking about before, if you have one of those condensers and you have a ducted system, it can plug right into that existing ductwork. It's really straightforward in that way and simple. So the next part is if you don't have ducts, Sam actually had, I think, mentioned you had ducts in your top of your house, and the bottom he didn't. There's air source heat pumps, so it's a very similar outdoor unit. They're often the same models, can do either one. And you can have these little indoor units, and that was in Sam's picture on the left. So if you don't have ducts, these are called ductless air source heat pumps. They're really common, really popular. I'm sure people have seen these little indoor units here that Sam had. Another popular but less common is ground source. So you can have a ducted system, and there actually are some now working with ductless, but essentially the heat is coming from the earth. And so instead of pulling the heat from the air, the contractor would dig up your yard or your parking lot or whatever and put all this piping down here and bury it. And what that would do is pull heat from the earth and pump it into your house and do the reverse. These have higher efficiency than the air source, and but are, as you can probably tell, a lot more complicated and more expensive to install, because you have to have the skill set, the contractors of people that can do the drilling of all this kind of stuff in your yard, as well as the heat pumps. But it's very popular. This is a new technology that is just coming out for people that have radiators and boilers like I have. These are called air-to-water heat pumps. So they're taking heat from the air, from the outside, and they're pumping it into the water that flows through your house. And these have been popular for a long time in Europe and Asia, and are just coming into stride in the US. One of the neat things about these is they can also heat your domestic hot water. So you can have one heat pump that does both, which is kind of nice. On the other hand, they're more complicated because they might not work with your radiators. I have in my house cast iron radiators, as probably a lot of people do in Havertown. And these are not, most people think that these are not able to get water hot enough for cast iron radiators. There's other type of radiators, like the ones, I don't know if you've seen, that are baseboard, that have the aluminum fin tubes, that these probably could work with, but the inside heat delivery system has to be evaluated at the same time. And there's active incentive programs in Vermont right now and Massachusetts giving incentive. And in New York, we're starting one March 1st to incentivize this technology. It may be hard to find local contractors comfortable with this technology today, but it's evolving very quickly. I think most people think that this radiator issue is going to be overcome over the next few years as the whole field switches to new types of refrigerants. And that's a whole nother story. But this is something to keep an eye on. I want to electrify my house too, but I can't right now. And I'm just going to be waiting a few years. Joy, I realize we have almost 10 minutes. We have a couple chaser slides on some local installs here on cost. Maybe I'll just go through this and we can do questions. Does that make sense?
Sounds good.
This is a local install for one of our EAC members, and we looked at the utility costs before and after the heat pump. So they had a gas furnace, and they switched over to a NEEP listed, so it's a cold climate Bosch, which is a really good manufacturer, with electric coil backup. So the backup was only there in case of you have a really cold snap, and it's replacing a gas furnace. So here is the average temp for 2 years before and after. This is the before, because you can see there's a lot of gas burned in this winter, and here is the same period after. So we just looked at it, and how much more would it cost to do this, or would it be cheap? And it's marginally cheaper here. If you look at it, this homeowner would save about $200 a year. It's not much. I would say if you're switching from gas to heat pumps, it's going to be something like this, a very small amount, kind of neutral, maybe paying a little more. On the other hand, if you're switching from oil or propane, or you use electric resistance, you're going to save a lot of money. Those are very expensive fuels to use. Gas is kind of a wash. Gas is so cheap where we live. And you're not going to go into this because you're going to save money. For gas, you're going to do it because your system is failing and or you care about the climate. But you're not going to pay significantly more. I think everything else here is stuff we've kind of covered. Incentives. Yeah, do you want to these are just
one of the things you didn't really cover this time that I want to make sure is pointed out is how much more energy efficient the heat pumps
Sure.
are compared to gas.
Sure.
So like you can get a really great efficient gas heater that has like 99% or 95% efficient. Do you want to explain how?
Absolutely. So yeah, like Joy said, the most efficient gas boiler is going to be like 95, and they're really expensive. But most of us have these clunkers, right? The old, the regular cheapest ones, they're 80% efficient. So you waste 20% of the heat goes up your chimney. Heat pumps, the efficiency is much higher. Over the whole winter and we've looked at a lot of data, even from way upstate New York, it's around, for the whole winter, if you look at it, about 220%-ish for air source. Ground source could be like 250. So your efficiency in using energy is at least twofold higher for a heat pump. And that's one of the attractions. Of course, the cost of the different fuels is your pocketbook question, and it depends on how they're priced. And like I said, oil or propane, it's a no-brainer to start thinking about heat pumps now, anytime, or electric resistance, because you will save quite a bit. And gas is going to be a kind of a wash.
You also have to think about it in a longer term game. If you have a solar array and you're paying, and I can take you for what I personally went through when we got our solar array. What we were paying for our loan, in terms of cost, was the amount we would have paid for the electricity had we not had the array. And then coupled with the heat pumps, now that our array is about to be sold, paid off from the loan, that'll be paid off within a year. The electricity that we get from the array that goes into the heat pump is essentially free. So when it's coupled with that system, which you can't couple with a gas heater, makes this a much more valuable way to think about it.
So we'd like to open this up to questions. We have a small group, so if you just want to unmute, you can ask questions or you can ask them in the chat.
What type of pots do you have to use for convection oven cooking?
You have to make sure that it has induction compatible metallic components. Some cookware is not compatible with induction. We actually had to go through all of our cookware when we used induction to see which one did work and which one did not. The higher quality stuff, the clad series, your higher quality cookware, the copper, I believe, works. Anything that can,
It's magnetizable.
anything that's magnetizable will work.
So cast iron, if you have a cast iron, that's definitely work. One thing, if a magnet, I've heard this, if a magnet sticks to it, it will work.
Okay.
And recently, actually, there's like it doesn't really increase the efficiency, but if, say, somebody brings over a pot to your house and you have an induction stove and their cookware is not induction friendly, you can get this, like, essentially this little piece of steel that you put on your induction cooktop, and then it heats up that steel, and then it will heat up the pot. So it becomes like a resistance heater for those times that if somebody comes to your house with something that is not induction friendly.
I'll just, I think we're almost at time. I don't know if there are any questions, but just close with, you can see how many different things there are, I think, on the second slide here, to do in your house. It's kind of bewildering if you care about climate, etc., of what of these to do. Please reach out to the Have Switch, and that's why we're doing this. We have people with plenty of experience that can talk through what, specifics about what you're doing and so forth. Another important thing, I think we touched on this, if any of your appliances are getting old, like Joy mentioned, if your domestic hot water heater is near 10 years, it's near the end of its life, it's going to break soon, you should really think about replacing it with a heat pump, as opposed to the middle of the night. when it will break, and you're just gonna put in the cheapest gas unit. That's how most people change equipment when things fail. Same with your furnace and your boiler. If they're near the end of their life and really old, it's time to start thinking about it now as opposed to when that stuff fails.
One thing you did answer for me is it's just my own curiosity. My nephew lives in Miami Beach on the 25th floor, and he replaced a vented dryer with one of those new heat pumps. And I asked him, where's the water go? And he didn't know, and now I know where it goes. So at least I've answered that question, because I was going to say, well, what about, where's it go? And he says, I don't know, but it did take a long time to dry our clothes. I will say that. Yeah. But at least I can give him a call now and tell him, Jay, I know where it went. So that's a good thing.
I also we recently got a new heat pump for our house, and we also got an electric resistance backup, but I set it so it will not come on unless it gets to 5 degrees Fahrenheit. And, we have not gone to 5 degrees Fahrenheit this winter, and like 1% of the time we might. And it's no guarantee that we would still need it then. But my house has been nice and toasty warm. I did not do, we have an insulated house, but it's not as sealed as Sam's, and we are warm without any backup.
And one plug for Pico here is you can get a home assessment, and they also do blower door tests as well. So that's like a no-brainer. This is I forget, they charge something very small for the blower door test, but that would really help you reduce the amount of heat you need. And everybody should do this. If you use fossil and you're never going to go to heat pumps, it's a no-brainer to do this.
All right, I'm being stupid. What is a blower door test?
Sorry?
What does a blower door test?
It's a pressure, they essentially open your front door and put a huge fan in there and shut all your windows, and they measure essentially how much air goes through the fan at a special pressure. And it really just, it's a standardized way to say how leaky your house is.
Okay, that's
And
what I
then
thought.
you can go around with the person and you can feel where the cold air is coming from. And all those things are super cheap and easy to fix. And that's like by far of anything we've talked about tonight, the cheapest and most impactful way to decarbonize whatever you're using for heating, period. So that's always the no-brainer first thing to do the air sealing. But they luckily Pico will do this for I think it's like $100 or something. But it's definitely worth if you're looking at going down this road.
And I did, when I was looking at the tax incentives, you can actually get a tax credit for up to $150 for those tests. So it's essentially free.
Awesome.
So we're at 8 o'clock. So I just want to thank you guys for coming, and please reach out if you have any questions. We're all volunteers here. We're committed to helping our community, so we want the community to reach out. Please don't be afraid to do that. Thank you.
And Sam and Steve, and of course, Joy, thank you. Well done.
And just to say how to reach out, have HAVSWITCH @gmail.com, haveswitch.com. Thank you.
Yeah.
Good night.
Thanks,
Bye-bye.
everybody. See everybody in the meetings. Okay. Bye-bye.